Okay, so we're going to talk a little bit about implicit differentiation and then do quite a few examples. The question is that some equations are defined implicitly. For example, the equation for a circle is x squared plus y squared equals to 1. So this would be the unit circle. So if we draw a little picture, we notice that, well, the circle isn't really a function, but even though it isn't a function, you can still find the tangent line at different points on the circle. So there should be a way to find the derivative of this function. Now, for the circle, you could define it implicitly for y by solving for y, but there are many other curves that you can't. So we're going to show how to do it with this example because it's one of the simplest ones, and then we'll get to some more difficult examples later on that require implicit differentiation anyways. So the basic idea is that you get the derivative of both sides with respect to x. Okay, now when you get the derivative of both sides with respect to x, well, the first part, the derivative of x squared, that's just 2x. Okay, now this isn't a problem, but let's take a look at over here on the side. Let's take a look at the derivative with respect to x of y squared. You see, y is a little bit different. Even though y isn't defined implicitly, y is a function of x. So if instead of thinking it as the derivative of y squared, think of it as the derivative of f of x squared. Okay, let me write it down here. Cut myself off right there. Okay, so if you think of it as the derivative of f of x squared, then really what you have to use is the chain rule, right? Because we have a function being squared, so the chain rule says, well, get the derivative of the outside function, which is this function f that's being squared, so this would be 2 times f of x times the derivative of f of x with respect to x. And now this, if we just rewrite it in a slightly different notation, we can write it as 2, now instead of f of x we'll put y, and instead of df of x over dx we'll put dy over dx. Different notation, but they mean the same thing. So this is what we have, and so the derivative of y is 2y dy over dx. And again, it's because of all of this that we just talked about, that y is a function of x. And this is equal to 0. And then what we're looking for, well, when we're looking for the slope of the tangent line, what we need to do is we need to find dy over dx. That's what we're trying to solve for. And so if we do that, well, we would first just bring the 2x over. And so we would have 2y times dy over dx is equal to negative 2x. And then we'll divide by 2y. And so we get that the derivative of y with respect to x is equal to negative x over y. And so this will give us the slope of the tangent line at any point around the circle given an x and a y value. And so that's how you do implicit differentiation. Okay, so we want to get the derivative of this function implicitly. So what we're trying to do is we're trying to find dy over dx, or in other words, y prime for short. Okay, so the first thing is to rewrite these square roots as fractional exponents. And then we get the derivative of both the left side and the right side. Okay, now the derivative of the left side, well, the derivative of x to the 1/2, that is just, if we do our little shortcut, this is just going to be 1 over 2x to the 1/2 on the denominator. Because when you bring the 1/2 over, subtract 1, it ends up being negative, and then so that means it's going to be positive at the bottom. Okay, so this equals 5, and if we apply the same little shortcut, we would have 5 over 2y to the 1/2, but then this time, since we got the derivative of y from the chain rule, we have to put a multiply by the derivative of y with respect to x, or y prime. Okay, and then we're trying to solve for y prime, so all we need to do is multiply both sides by 2y to the 1/2 over 5, which is a reciprocal. So we'd have 2y to the 1/2 over 5. And so these cancel. And so in the end, what we have is y prime is equal to, here the 2's cancel, y to the 1/2 on top, or square root of y, over 5 square root of x. And that's it.